CicuDevices. Impella, Chapter 1, Physics and Physiology, Part 3. Physiology. The pump suctions blood from the ventricle through its inlet and ejects it towards the outlet in the sending aorta or pulmonary artery. Since the device consistently empties the ventricle during both systole and diastole, it diminishes both afterload and preload. This is a normal pressure volume in loop, with a specific end-diastolic volume-pressure relationship and systolic pressure-volume relationship, along with a particular curve width of the curve, which correlates with stroke volume. When cardiogenic shock occurs, contractility decreases, end-diastolic pressure increases, and the width of the curve narrows, indicating a decrease in stroke volume. The Impella implantation results in pressure-volume loops under left ventricle support, showing a leftward shift and a triangular shape, with a decrease in end-diastolic pressure and volume. It also leads to an improvement in the end-systolic pressure-volume relationship and a significantly reduced pressure-volume area. This aspect indicates that the ventricle performs less stroke work, resulting in a decrease in myocardial oxygen consumption. In contrast to other support methods, extracting blood from the left ventricle is not dependent on ejection through the aortic valve. With higher pump flow rates, the left ventricle experiences greater unloading. This results in a reduction in myocardial oxygen consumption. Concurrently, arterial pressure rises, causing a growing disconnect between peak left ventricle pressure and arterial pressure. This phenomenon is called uncoupling. The direct unloading also leads to lowered left atrial and wedge pressures. The Impella device inserted in the left ventricule augments blood flow, leading to improved organ perfusion. It also elevates mean arterial pressure, enhancing both organ and coronary perfusion, and consequently increasing oxygen supply to the myocardium. Another effect is the decrease in end-diastolic pressure and volume, resulting in a reduced wall tension, microvascular resistance, and enhanced oxygen delivery. Additionally, it lessens mechanical workload and decreases oxygen demand. Regarding the Impella RP, implanted in the right ventricule, the device generates an increase in pulmonary flow with a subsequent increase in left ventricular preload and cardiac output, leading to an increase in organ perfusion. On the other hand, the catheter causes a decrease in pressure and end-diastolic volume of the right ventricle, reducing mechanical work and, consequently, oxygen demand. Finally, the device improves myocardial oxygen delivery by increasing cardiac output and reducing wall tension.
If you've enjoyed our video, please press the like button and subscribe to support us so we can continue creating quality content like this.